Hey guys, so today I'm gonna talk to you guys about a system of inequalities. But before I do, I just want to do a quick review because systems of inequalities, like system of equations, are related. Is that the word I'm looking for? They're similar. So quick reminder, and I'm just gonna draw two random lines. If you have two linear functions, they will intersect either at one point, like we see here. That point is 1, 2, 3, 4, 4,1. 4,1 is the solution to the system. Or you may have where the two lines never intersect. So that would mean there's no solution. Or that they always intersect would mean that there are infinitely many solutions. So for a system of inequalities, instead of looking for a point of intersection, we're looking for areas where the region created by the inequalities overlap. So to kind of get us started, I'm going to do a simple system of inequalities. So y is greater than 2 and x is less than or equal to negative, 1. So when you have y is greater than 2, y cannot equal 2. Because if it does, then 2 is not greater than 2. That's false. So we're going to have this solid line as opposed to a solid line. So y is greater than 2 would be something like this. A solid line because it technically cannot equal 2. And the difference between a system of inequalities is we're going to shade these regions where y is greater than 2. So that region includes 3, where y is 3, because if y is 3, 3 is greater than 2. Where y is 4, because 4 is greater than 2. And where y is 5, because 5 is greater than 2, and so on and so on. A million, a gazillion, a quadrillion, whatever, all the way to positive infinity. So we are going to shade this entire region above because that includes values that are greater than 2. Now for x is less than or equal to 1, x can equal negative 1. That is a delete sign. X can equal negative 1 because negative 1 is less than or equal to negative 1. It's equal to it. So we're going to have this solid line where x is equal to negative 1. So let me try to do as best of a straight line as I can. All right, my arrows are not that good. And again, we're going to look for the region where we have more values. For example, x can be negative 2 because negative 2 is less than or equal to negative 1. It's less than. And negative 3, and negative 4, and negative 5, all the way to negative infinity. So here we're going to shade basically to the left where all the values of x are less than or equal to negative 1. Now here you'll see this area where they overlap, and to kind of highlight it, I will highlight it with yellow. So this is the region where the two inequalities are overlapping. I'm going to go ahead and erase the regions where, whoops, I did not mean to erase part of that solid line, and it's going to do it again. All right, so I still have part of it. And it's going to be a lot easier for you guys on paper with pencil or colored pencils or colored pens, whatever you have. Coloring will definitely help. So this is the entire region now. Like a system of inequalities, there are going to be points, but except this is an entire region. So a point that satisfies this inequality has to be in that region. So just to kind of point out a point, I will go ahead and say, let's use this random point. That point is negative 1, negative 2, negative 3, and 1, 2, 3, 4. So that point is negative 3, positive 4. So that means that x is negative 3 and y is 4. And again, I just picked a random point. And I'm going to show you guys how this satisfies the inequality. So for the first inequality, from that point that I selected, y is 4 and 4 is greater than 2. And from that point, my x is negative 3. So negative 3 is less than or equal to negative 1 is absolutely true. So this point satisfies both of them. And there's more points that we could have picked. I could have picked this corner point over here. Let me see if I can actually draw a point there. And that point is -1, -2, -3, -4, -5, -6, -7, -8. 1, 2, 3, 5, 6, 7, 8, 8, comma 8. So again, that would also satisfy both of the inequalities, but now instead of having 4 and -3 for x and for y, they both have 8. And again, 8 is greater than 2, and 8. Oh my gosh, did I make this simple mistake? X was -8. So -8, comma 8. -8 is less than or equal to -1. I was like, why is it not making sense? And that's because I messed up on my x. It was -8, comma 8. And there's a whole lot more points, obviously, but I can't. We have a small coordinate plane. And just to quickly show you guys why the other regions that I erased were not part of the solution is because it won't satisfy both inequalities. It'll satisfy the region for the inequality that was shaded, but not for the other one where it didn't have shade. So if you guys remember, I had all of this red and then over here all of this blue. So if I pick a random point, I'm going to draw a point there. I'm going to make it a little bit thicker. That point is 1, 2, 3, 4, 4, comma 1, 2, 3, 4, 5. It'll satisfy the first inequality because that was part of the shaded region for it, but it won't satisfy the second one because it wasn't shaded blue, for example, here. So it's not part of that inequality. But just to prove it to you guys, let me go ahead and erase this. It'll satisfy the first one, but not the second one. So using that point, y is 5. So I'm plugging in 5 for y. 5 is greater than 2. And like I said, it would satisfy it because that point is part of the red region, which was the region for the first inequality. Y is greater than 2. But it wasn't part of the blue region or the inequality x is less than or equal to -1. So that x there is 4. So when I plug in 4 here, 4 is not less than or equal to -1. Okay, so it doesn't work. So that's why this is not a solution. You can only pick points in that region, but for inequalities, we just shade in that region when we're graphing. I'm going to show you guys another system of inequalities that's going to be a little bit more complicated. I did that system first because it's a little bit simple to start you guys off. So for the next system of inequalities, it's going to look a little bit more complicated, but I'm still going to try to keep it as simple as I can because I'm going to make both equations in slope-intercept form, which will help us graph. So for the first inequality, I'm going to have y, I don't know, is less than or equal to -x plus 4, and then y, just to make it different, is greater than -3x plus 6. So for the first equation, or inequality, I shouldn't say equation. For the first inequality, I'm going to identify my slope m and my y-intercept b. So the slope m is always the coefficient in front of x. A lot of students get scared right here because they're like, there's no number. There's a negative sign, but there's no number, but there's technically an invisible one there because we have one -x. So -1 is my slope. And the y-intercept b is 4. Now, we are going to go ahead and plot b on the y-axis. So b is 4, 1, 2, 3, 4 here. And then we're going to use our slope, which is -1, to rise and run. However, this is not a fraction, so any number that's not a fraction, we put a 1 under. So that tells me that I'm going to rise 1 and run 1, 1 and 1. However, it's a negative slope. So if you guys remember, I talked to you guys about slope penguins. When it's a negative slope, it's like a penguin sliding down a mountain. So I already have a clue that my line needs to look like this. So that means I'm going to go up 1, left 1. That way I start creating this line that has a negative slope. So up 1, left 1. Now I'm going to go back to my y-intercept b and go the opposite direction. So instead of going up 1, I'm going to go down 1. And then same thing, instead of going left, I'm going to go right 1. So down 1, right 1, and just keep going. That's just me. I have OCD, down 1. And as soon as you have all these points, we can draw either a solid line or a dashed line. Now, because this is less than or equal to, that means that it is equal to, so this is actually going to be a solid line. Ooh. Ooh. Stylus pen do a straight line. I mean, I could try to do one like that. But oh well, you guys will have better luck with paper and pencil. Now, as far as shading, there's going to be a lot of shortcuts. My go-to is imagine the origin. So it's going to look. So imagine the origin, 0, 0. If the origin satisfies this inequality, then we're going to shade towards the origin. And if it doesn't, then that means we don't shade towards the origin, so we shade the opposite direction. So I like to test out points. That's me doing math. I think there's going to be some other YouTube videos that are going to explain like all these shortcuts, but they don't always work, especially when they're not in slope-intercept form. So I am going to say that we should test the origin. So 0, 0. So x is 0, y is 0. So I'm going to test it with this inequality. So y is less than or equal to negative x plus 4. So instead of y, I'm going to put 0 is less than or equal to. And you can't have negative 0. I am plugging in 0 for x, but you can't have negative 0. There's no such thing. So I am just going to put 0 and then plus 4. Everything else stays the same. So again, the only thing that changed in this inequality was y and x. Plugged in 0. And there's no negative in front of 0 because there's no negative x. And now we check to see if that origin satisfies this inequality. So 0 plus 4 is 4. And it does satisfy the inequality because 0 is less than or equal to 4. So that means I'm going to shade this entire region here where the origin was at. All right. Now for my second inequality, we're going to do the same steps to graphing. We're going to identify the slope m, which is the coefficient in front of x, so negative 3, and the y-intercept b is 6. Again, and let me fix this because it kind of looks like a 2. It's negative 3. We usually want a fraction for our slope because of the rise over run, so I'm going to already put the 1 under. The next step is to plot b on the y-axis. So b is 6, that's my y-intercept. So 1, 2, 3, 4, 5, 6 goes there. Oops, wrong one. And then, again, this line, it's a coincidence, has a negative slope, so it's going to look like the blue line where we can imagine a human going down, except it's going to be steeper. Can't technically rise 3 because I don't have the space for it, but I'll be off the grid, but that's okay. So 1, 2, 3, and then left 1. And then the opposite way. Instead of up 3, I'm going to go down 3, and instead of going left, I'm going to go right 1, down 3, and keep going. That's just going to give you a pure line. The more points you have, well, that's just me right now because I'm doing this on the Chromebook and with the stylus. You guys, again, are going to have better luck with the pencil and paper. Now, as far as shading, again, my go-to is always to use the origin just because it's so easy just to plug in 0 for x and for y. So I'm going to test the origin with this second inequality. So again, I'm going to plug in 0 for x and 0 for y because I'm just testing the origin. If origin 0, 0 satisfies it, then we're going to shade wherever the origin's at, that entire region. So because this is a steep line, I'm going to say to the left of this line. Or if it doesn't satisfy it, we're going to shade towards the right. So again, my inequality was y is greater than negative 3x plus 6. So instead of y, I'm testing the origin. So I'm going to plug in 0. And then negative 3. And again for 0, or for x, I'm plugging in 0 plus 6. So then we're just going to do some simple math. Negative 3 times 0. Negative 3 times 0 is 0. And then 0 plus 6 is 6. So 0 is greater than 6. Wait, what am I talking about? Oh, it's 1050. 0 is not greater than 6. 0 is less than 6. So this is false, which means the origin doesn't satisfy this inequality. So that means I'm not shading towards the origin, I'm shading away from the origin. So I can't include the origin. So basically think of it as shading to the right of the line because the origin is to the left. So I'm not shading that way. And now, as if you guys can see, and it's kind of hard to see because the point, this region is kind of stuck in between the lines there. So that's the region that where the inequalities overlap. So I'm going to erase the parts where they don't overlap as best as I can. And then here, whoops, let me erase that. Now, just to prove to you guys what this means, I am going to pick a point on this region. I'm going to go ahead and erase the slopes and my intercepts. So, I'm going to test the point, and I will just test, I don't know, I'll pick this random point here. It's part of the region. So the x there is 1, 2, 3, 4, 5, 6. And the y is -1, -2, -3, -4, -5, -6, -7. So 6, -7. So that means at this point, which is part of the region, x is 6 and y is -7. So what I'm going to do is I'm going to show you guys that this point, and literally any point that's in this region, will satisfy both inequalities. So for the first inequality, I have y, and y is -7, is less than or equal to negative, and now x is 6 plus 4. So we're going to do just some simple math here. So I'm going to leave the -7 alone. And -6 plus 4 is -2. -7 is less than or equal to -2 is absolutely true because it's less than. Now for the second inequality, where we have y is greater than -3x plus 6, again for y, I am plugging in -7. So -7 is greater than -3. And for x, I am plugging in 6 and then plus 6. So we're going to do some simple math. -3 times 6 is -18. And -18 plus 6 is, oh gosh, I can't do math now, -12. And -7 is absolutely greater than -12. I know some of you guys get confused with your negatives, but yes, -7 is greater than -12. So this point and all the points in this region satisfy your system, which includes these two inequalities. If you pick a point on a region, because this is going to get more and more complicated, but if you're confused about the region, just pick a point and test it. If it satisfies both of them, then that's absolutely correct.